Hello and welcome to this clip going through a multiple choice question which requires you to balance an equation using oxidation numbers. So this is actually quite a difficult question because it doesn't say specifically that you have to use oxidation numbers to achieve it. But it is the only way really around what is otherwise quite a tricky one to do using older style techniques that would have been taught at GCSE. So a big clue that it's a redox reaction in the first place is that the copper is found as an uncombined elemental form. So the fact that it's turning into a compound from an uncombined element means its oxidation number is going to change from 0 into something. So that tells you that it's a redox reaction. Now, if you've had a go at this type of question and found it difficult, it's because it really requires the use of oxidation numbers, but they're not saying that, as you can see in the question. So let's have a look at how we could do this. So if we take the equation again, first thing to do is to assign oxidation numbers to all the ones that you can obviously do from the oxidation number rules. So that would be your copper, your hydrogen, your oxygen, etc. The next thing to do is to deduce the less obvious element, so that's nitrogen in this case. So in the nitrate ion in HNO3, oxygen is -2. So for the whole charge on the ion to be -1, nitrogen must be +5. And in NO2, on the right hand side, oxygen is still -2, so for the compound to have an overall oxidation number of 0, seeing as it's obviously neutral, there's no charge there, N must be +4, like that. So the next thing to do is to work out what's been oxidized and reduced. So the copper has been oxidized from 0 to +2, so 2 electrons have been lost. Now in copper nitrate, the nitrate ion stays the same as it was in HNO3. So that particular nitrogen atom is unchanged. So that can be also written as +5. So that can be left out of the oxidation reduction equation, in that you don't have to worry about redox taking place with that particular nitrogen. But the nitrogen in HNO3 has definitely been reduced from +5 to +4, as you can see, so 1 electron is gained. So let's take this information and do something with it. If the oxidation process involves the loss of 2 electrons, then the reduction process has to happen twice to support this, because each reduction process in this particular equation only involves the gain of 1 electron. So you have to gain 2 electrons to support the loss of 2 electrons. So your reduction has to happen 2 times. So you can put a 2 in front of the HNO3 and a 2 in front of the NO2. So that means the reduction has happened twice now. But we have a bit of a problem. It's not yet balanced for nitrogen because, like we said earlier, some of the nitrogen ends up as NO3- in copper nitrate. So what you do here in this situation is double up. So we need to double up the HNO3 and double up the NO2 and then balance for hydrogen in water to compensate. So if we come back to our original question and put those balancing numbers in, we can clearly see that there are 4 moles of HNO3 that react with 1 mole of Cu. So that means answer C. Okay, so hopefully this has been a useful insight into how to do quite a difficult oxidation number question. Until next time, thanks for listening and see you soon.